Okay, we're now going to look at what I think was, without a doubt, one of the most difficult questions on the entire exam. This is paper 2, exercise 3. This is a probability question, but it's a probability question that a lot of people made mistakes on. I'm going to hopefully try to illustrate how you should really do it and why that would work. But again, we'll go through it as we think about this. Andre will play in the semifinal of a tennis tournament. If Andre wins the semifinal, he will progress to the final. If Andre loses the semifinal, he will not progress to the final. If Andre wins the final, he will be the champion. The probability that Andre will win the semifinal is P. If Andre wins the semifinal, then the probability that he will be the champion is 0.6. Then it says complete the values in the Venn in the tree diagram. Okay, first thing to keep in mind is many people, I'm just going to point this out now, this was a very common mistake, was to go, oh, but I see this 0.46 down here, I'll just put that in up here. No, this is not the way forward. And the reason this isn't the way forward is because, firstly, that's not how this is meant to be understood. But as a secondary point, and this is a much more general point about IB exams, on an IB exam, no information, all information needed, I should say, is presented before the question, not after. So, for example, to solve this problem, you do not need to know this value down here. And in fact, you're not supposed to know it. You have to make do with what you've got from up here. Basically, everything before this, that's what you have to work with. Everything afterwards, no. So, okay, complete the values in the tree diagram. Well, let's read this. The probability that Andre will win the semifinal is P. If Andre wins the semifinal, so basically, if we're up here, once we're in there, the probability that he will be the champion is 0.6. Okay, so he has a chance of being the champion once he's already up here of 0.6. That must be what we put here. Now, think about tree diagrams. Every single tree must add up to a certain probability. The particular probability that it has to add up to is 1. There must be just as much chance of him going up as there is for him to go down. So those are the numbers we're going to put in here. 0.6 and 0.4. Okay. Next, the probability that Andre will not be the champion is 0.46. Find the value of P. Okay. So this is a somewhat tricky question, but we're going to have to think very carefully about how we approach it because it's not necessarily trivial. Let me try and illustrate the way that it works. What cases up here have him not being the champion? I'm going to highlight them in red. Well, the obvious one is if he loses in the final, he's obviously not the champion. Okay. But he could also lose in the semifinal. Then he's also not the champion. So the probability is if he lands in either of these cases, well, then he's going to not be the champion. How do we calculate that? Well, you might think it's 1 minus P and then plus 0.46, but that's not totally right. We have to remember that in order for him to end up on this particular line, he has to go through 2 markers. He has to have been through this, and then also he has to go here. Down here, he only has to go through 1 marker. So 2 markers versus 1 marker. Okay, how do we calculate that? Well, the probability of 2 events happening in a row is just the probability of each one times each other. So it would be P times, and I'm just going to do this very, very ugly, times 0.4. Then the other one would be 1 minus P. In other words, but those two, once you have those probabilities, you can simply add those 2 up because those are the true probabilities of each event on their own. That should be equal to, according to this problem, 0.46. Now, this is my favorite way of addressing probability. You'll notice that I haven't used any formulas. I haven't used the data booklet or formula booklet. I have just explained it basically in a way that I hope is understandable. So with this system, now comes the question, how can we figure out what P is? Well, you might be tempted to go, well, we can do this by hand, we can isolate for P, but why? Why even do that? You're on paper 2. Remember that the GDC is your friend. Remember that it is an option. So I'm going to open up the GDC and I'm going to type this equation into NSolve, and then I'm going to see what it gives me. So I'm going to do P times 0.4 plus 1 minus P. And then I'm going to solve it for P. And hopefully it should give me an answer once I set the appropriate sizes. And oh, lo and behold, how nice. So now, if I look at the NSolve that I've done, what I'm going to see is this. If I do this particular problem up here with NSolve, I get this probability. So it tells me that P in my case here, or in this question's case anyway, P is equal to 0.9. I'm going to make a slightly nicer equal sign than that. But yeah, this is your answer. And this is the technique to find it. It is possible to use more, it is possible to use the data booklet for some of these, but the problem is that at the end of the day, you're going to see this exact same equation sooner or later. You're going to see this come up. It's just a question of, can you explain it yourself, or are you going to find a data booklet explanation? I find it very complicated to remember the data booklet and formula booklet explanation, and I've never found it useful. I'm hoping to be able to impress that onto you as well, that my experience is that it is best if you can think about probability in a more natural way than trying to formalize it into equations and silly formulas and things like that. I don't think that that helps. So that's my opinion. Let's move on to question C, because that's technically B done now. We have found the value of P is 0.9. Given that Andre did not become the champion, find the probability that he lost in the semi-final. Okay, so this question asks a lot. Now, again, let's start with what isn't an appropriate answer here. The answer is not 1 minus P. The reason this is not the answer is because remember that it asks, given that Andre did not become the champion, it tells us, okay, we're in these two cases. These are our cases to choose between. We completely ignore this one. That one is not even on the table. What is the probability, once we ignore this option, that we are in this option? That's basically what we're asking. We're modifying the problem in this question to not even include this probability, but only have this one and this one, and then try and see, well, we have to rescale everything so that it's, so that it works. What should the new probabilities be? That's basically what we're doing. In order to do that, here is the system. Take the total probability that there is associated with these two. We just found it, by the way, or it was given to us. We know that the probability of, I'm going to show this in red, we know that the probability of all the red options that I've shown happening, like the total probability of that is 0.46. That's what we were told. Let's use this as our new basis. This right here, this is all of our cases. This is our new one, in a sense. So that means that we do 1 over 0.46, multiply it onto that to turn it into 1. That's our system. We're going to do the same thing to the probability that this had before we rescaled it. Right now, this has a probability of 1 minus P, or 0.1, if you remember what P is over here. So that means we're going to take 0.1, we're going to multiply 1 over 0.46. Let me draw the line. we're going to multiply this 0.1 with 1 over 0.46. And we're going to see what it gives us, because that should be the real probability. So 1 over 0.46, I can do this on the calculator and I can get 0.217. And that should be the result. This is the probability. If we already know that he's not the champion, then the probability that he must have lost in the semifinal becomes this big.